So if we want to solve an equation, that is, if we want to find out what the solutions are, how can we do that? Well, exactly what steps we want to take depend on the structure of the equation. But there are three basic moves that we'll use for every kind of equation, and these will let us solve any linear equation in one variable in a pretty straightforward way. So the three moves that we have available to us to solve any equation are: first, we can simplify the expressions on each side. So if we have a complicated expression on one side of an equation, we can simplify that expression to get a simpler equation. Second, we can add or subtract the same thing on both sides. And when we talk about the same thing, we mean a number or a variable expression. We can do that with any number or any expression we choose, though of course we're going to strategically choose what number or expression to add or subtract in order to end up with a simpler equation, an equation that's closer to being solved. The other move we have available is to multiply or divide by the same number, as long as that number is not 0. Right? We can't multiply both sides by 0 because that just gives us the equation 0 equals 0, which is not interesting. We can't divide both sides by 0 because you can't divide by 0 at all. Because we want to make sure that we're not dividing by 0, we will not, at this point, divide both sides of an equation by a variable expression. Multiplying or dividing both sides of an equation by a variable expression is a more advanced technique, which you'll see if you take a more advanced algebra class. But as a basic move, we're only going to multiply or divide by a known number that we know for a fact isn't 0. So when I say that we can do these things, when I say that these moves are available, what I mean is, if we do any of these three things, the new equation that we get is what's called equivalent to the old equation. So what does it mean for two equations to be equivalent? It means they have the exact same solutions. Our ultimate goal is that we're going to get an equation that looks something like x equals 7. We know that that's only true when x really is 7. But we can use various steps, various sequences of these moves to get from one equation that doesn't look solved to another equation that doesn't look solved, and still have them be equivalent. In example 17, we're saying that this equation, 2x plus 3 equals 7, and this equation, 3x minus 1 equals 5, we're saying that those are equivalent equations because they have the same solution. And the solution we're talking about is x equals 2. So the claim I'm making is that if I plug in x equals 2 to the first equation or to the second equation, both of them are true. So in the first equation, plug in x equals 2, we'll have 2 times 2 plus 3. So 2 times 2 is 4, plus 3. 4 plus 3 really is 7. 2 really was a solution. In the second equation, plugging in x equals 2, we'll have 3 times 2 minus 1. 3 times 2 is 6. And then 6 minus 1 really is 5, which is the number on the right side of the second equation. Both of those equations have the same solution, x equals 2. And so those equations are equivalent. There is a sequence of moves out of 1, 2, and 3 that we could use to take us from the first equation to the second equation. We usually wouldn't do that, though. Usually the moves that we're going to choose are moves that take us closer to something that looks like this. Our goal when we're solving an equation is to find out the value of the variable. The way that we're going to develop our technique of solving equations is by starting with the simplest possible equations and growing a little bit more complex step by step. So the simplest possible equations are what are called one-step equations. In a one-step equation, only one thing is happening to the variable. So in example 18, we have x plus 5 equals 11. 5 is being added to our variable x. So in order to solve the equation, we want to do something to both sides. And what we want to do to both sides is whatever is the opposite of what's happening to the variable. So the opposite of adding 5 is subtracting 5. We want to subtract 5 on both sides of the equation. And now, first I'm going to show you all the details of what that looks like. And then I'm going to show you a shortcut way of writing that. So we start with x plus 5 equals 11. And now on each side of the equation, we're going to subtract 5. Then we will combine the numbers, right? So we have plus 5 minus 5. That works out to 0. Over here we have 11 minus 5. That works out to 6. And so we end up with x equals 6. As a shortcut way of writing that, starting again with our original equation, x plus 5 equals 11. When we're adding or subtracting a term, we might write it just underneath the equation. And we're going to write the number we're adding or subtracting on each side. So we need to do this once on the left side of the equation, once on the right side of the equation. We're going to write the number that we're adding or subtracting underneath the like term. And then, because plus 5 and minus 5 add up to 0, we'll cross those out. And we're left again with x equals 6. So this is what's really happening. This is a writing shortcut. And I'm going to use the writing shortcut for the rest of this video. But if you want to write out the gory details, if you find that helps you keep track, that's absolutely okay. In this next example of a one-step equation, we have 2/3 just written next to x. Remember, when a number is just written next to a variable, it means multiply. So here x is being multiplied by 2/3. And so again, we want to do the opposite of that. The opposite of multiplying by 2/3 is going to be dividing by 2/3. And notice just the number 2/3 is what we're dividing by. We're not dividing by 2/3 x. We're just dividing by the number 2/3. So we have our equation, 2/3 x equals 10. And the way I'm going to write this is I'm going to just write divided by 2/3 on each side. And so we'll get x equals 10 divided by 2/3. We could do fraction arithmetic to work that out, or we could use the calculator. So we'll take 10 divided by, in parentheses, entering 2/3 as 2 divided by 3, and we get that that is 15. So we get the solution x equals 15 to this equation. Now that we know how to solve a one-step equation, The next simplest equation is what's called a two-step equation. In a two-step equation, the variable still only appears once, but now two things are happening to it. And they're things that we cannot combine by simplifying. So it must be that there's addition or subtraction, and there's also multiplication. So order of operations says that multiplication happens before addition. In order to reverse that, we're going to first reverse the addition, then reverse the multiplication. So our example two-step equation is 4x minus 7. So notice what's happening to our variable. First it's multiplied by 4, and then 7 is subtracted. So we're going to get rid of the subtracting 7 first. The opposite of subtracting 7 is adding 7. So the first thing we're going to do is to add 7 on both sides. So we have our original equation, 4x minus 7 equals 9. We'll add 7 once on the left, add 7 once on the right. Subtracting 7 and then adding 7 cancels out, and we're left with 4x on the left. On the right, 9 plus 7 is 16. So now we've gone from the equation 4x minus 7 equals 9 to the equation 4x equals 16. Of course, this is now a one-step equation. In order to get x by itself, we still need to get rid of that multiplication by 4. The opposite of multiplication by 4 is division by 4. So our next step is to divide by 4 on both sides. So we're beginning with 4x equals 16. We divide by 4 on the left. We divide by 4 on the right. On the left, multiplying and then dividing by 4 cancels out. On the right, and so we're left with x on the left. On the right, 16 divided by 4 is 4. And so our solution is x equals 4. Now, when we've just solved an equation, we can always check. We can always know for sure whether our answer is right or not. To check whether our solution is correct, we just plug in this value to the original equation. So we're going to plug in our solution, x equals 4. We'll have 4 times 4 minus 7. And then we'll work out 4 times 4 is 16. 16 minus 7 is 9, which is the number that we had on the right side of our original equation. So if x equals 4, that really does make the original equation true. Okay, now we know how to solve a two-step equation. What if we have an equation in which the variable appears more than once? In particular, what do we do if we have an equation in which we have a variable term on both sides? Well, in that case, we want to get rid of that, right? We want to get rid of the variable term on one side. And whenever we're trying to get rid of an entire term, we're going to either add or subtract. And as a general rule, I'm going to choose to eliminate the variable term on the right side of the equation, just because that's going to give us a variable on the left, which is something that we like. And that way we don't have to spend a bunch of time thinking about which side to eliminate the variable on. So in this equation, I see a 2x on the right. I want to get rid of that, right? I want to make that 2x go to 0. So I want to subtract 2x from it. I'm going to subtract 2x on both sides of my equation. And then after that, I'm going to simplify. In particular, I'm going to combine like terms. Because when I combine like terms, then I'm going to be left with just one variable term on the left. And my hope is if I've chosen the right thing to subtract, I'm going to be left with no variable terms at all on the right. So first I'm going to show you the gory details. And then again, I'm going to show you writing this in the shortcut way. So we've got 5x plus 4 on the left. I'm going to subtract 2x there. And then we have 2x minus 5 on the right. I'm going to subtract 2x there as well. So now I'm going to combine my like terms. On the left, 5x and minus 2x are like terms, so I'll be left with 3x. And then nothing's happened to the 4, it just stays a plus 4. On the right, I have 2x minus 2x. Whenever I subtract something from itself, I just get 0. And so I'm left with 3x plus 4 is just negative 5. Again, writing this in the shortcut way, I've got 5x plus 4 equals 2x minus 5. I'm going to write the term that I'm subtracting, and I'm always going to write it underneath the like term. Right, so since these are x terms that I'm subtracting, I'm going to write them underneath x terms. So 5x minus 2x gave us 3x. There was nothing like the plus 4, so we leave the plus 4 alone. 2x minus 2x cancels out, and on the right, I'm just left with minus 5. Now here's the neat thing, right? Now that we've subtracted the variable term on one side, we now have a two-step equation, which we already know how to solve. We're now solving the equation 3x plus 4 equals negative 5. And so first we need to get rid of the plus 4. We'll subtract 4 on both sides. So starting with our 3x plus 4 is negative 5. We'll subtract 4 on the left, subtract 4 on the right. On the left, 4 minus 4 cancels out, and we just have 3x. On the right, negative 5 minus 4 is negative 9. And if you're not comfortable with the arithmetic of negative numbers, you can use a calculator for that subtraction. Okay, so 3x equals negative 9. X is almost by itself. We just need to get rid of the 3. And to do that, x is multiplied by 3. The opposite of multiplying by 3 is dividing by 3. So we want to divide by 3 on both sides. So we have 3x is negative 9. We want to divide by 3 on the left, divide by 3 on the right. On the left, multiplying by 3, then dividing by 3 cancels out, and we just have x by itself. On the right, negative 9 divided by 3 is negative 3. And so we're just left with x equals negative 3 as our solution. Of course, whenever we've just solved an equation, especially a new kind of equation that we're not certain about, we'd like to check. So I'm going to plug in x equals negative 3. On the left-hand side, I'll have 5 times negative 3 plus 4. That's negative 15 plus 4 is negative 11. On the right, we'll have 2 times negative 3 minus 5. That's negative 6 minus 5. That's also negative 11. So since those gave us the same number, x equals -3 really is a solution. Okay, so those are the basic kinds of equations. The last thing we need to talk about is, what do we do if we have a linear equation in one variable that doesn't immediately look like any of those? So in example 22, we have 29 minus x equals 11. And we might think that this is a one-step equation because there's only one thing happening on the left-hand side. We just have one operation, just subtraction. But that's not something that's happening to x. X is being subtracted from 29. So we can't just undo something that's happening to x, because nothing's happening to x in this equation. Something is happening to 29. And our goal isn't to solve for 29. We know the value of 29. It's 29. So what can we do? Well, we have to remember for an equation like this that there's no such thing as subtraction. This equation is actually 29 plus the opposite of x equals 11. And now we see that this is actually a two-step equation. So we know what we need to do now in order to solve for x. First, we need to get rid of the 29. We'll do that by subtracting 29 on both sides. And that subtraction really is a job for a calculator. We'll get -x is -18. And then we need to get rid of the negative sign on the x. And there are a number of ways you can think of this step, but I think the easiest way to think of it is -x means -1 times x. And so in order to get x by itself, we need to divide both sides by -1. On the left, -x divided by -1 will be just x by itself. On the right, -18 divided by -1 will be +18, which gives us x equals 18 as our solution. And we can check that. We can check that if we plug in x equals 18, well, our equation becomes 29 minus 18, which really is 11. Yes. Okay. The other reason that we might have something that doesn't look like a one-step equation, a two-step equation, or an equation with one occurrence of the variable on each side, is that we have an expression on one side of the equation or the other that needs to be simplified. That's happening here in example 23. So in example 23, the left-hand side of our equation is this big complicated expression. And then the right-hand side is just the number 26. So as our first step, we're going to simplify. And then once we have that expression simplified as much as possible, then we can put that back in and solve some expression equals 26. So our first step is figuring out the simplest possible expression in x for what equals 26. Okay, so when we're simplifying this expression, we're going to follow the order of operations, which says multiply and then add. So that means that we need to simplify this 5 times x minus 1 before we can simplify any of the addition. So here we have subtraction inside, multiplication outside. This is a job for the distributive property. Now at this step, nothing's happening to the 12. Nothing's happening to the 4. In this term, we have 5 times x is 5x. 5 times minus 1 is minus 5. So now we've distributed. Now there are no parentheses. All we still have left to do is to combine any of our like terms, including combining any numeric terms. I only have one variable term here, 5x. I'm going to put that at the beginning. Then I have 1, 2, 3 numeric terms with no variable. I'm going to put those next. So I'll have a plus 12, a minus 5, and a plus 4. Okay, well, I can just go through and combine these from left to right. 12 minus 5, not doing anything with the 5x. But then 12 minus 5 is 7. And then 7 plus 4 is 11. So that complicated expression on the left simplified to 5x plus 11. Okay, and now I'm looking at my new equation. I see that that's a two-step equation, so I know how to solve. First, I'll subtract 11 on both sides. I've got 5x is 15. Then I'll divide by 5 on both sides, and I'll get x is 3 as my solution. And as always, if I've solved a kind of complicated equation, I want to check. I'm going to plug in x equals 3 on the left. So I'll have 12 plus 5 times 3 minus 1 plus 4. And I could work through that whole thing, or I could just throw that whole thing into my calculator. We'll say 12 plus 5 parentheses 3 minus 1 plus 4. And that really does give us 26, which is what we hoped to see. So now we can solve one-step equations, two-step equations, and equations in which the variable appears on both sides. If we have an equation that does not appear to be one of those, then we need to manipulate it a little bit until we can see that it is one of those types.